Hello, friends and folks. For today, I will explain inverse variation. What is inverse variation? The inverse variation in mathematics, it is the type of variation of two quantities where an increase in the first quantity causes a decrease in the second quantity. So in this illustration, if this is our first quantity, as we increase the first quantity, it causes or produces a decrease in the second quantity. Okay? Suppose our two quantities are x and y. Two quantities are x and y. So as we increase the value of x here, it causes a decrease in the value of y. Or conversely, as we decrease the value of the first quantity, say x, it causes an increase in the second quantity y. And this illustrates simply inverse variation of two quantities. In statement, to make it clear, so an increase in our first quantity, since we have two quantities, an increase in first quantities causes a decrease in second quantity. So an increase in first quantity, this is quantity, okay. An increase in first quantity causes a decrease in second quantity. Okay, so in symbol, this is where we will define inverse variation. So the inverse variation looks like this. In symbol, say we have two quantities, so we have in symbol y equals, this actually the product of our constant k, then the inverse of the other quantity. Okay, so to simplify, y equals k times 1 over x is simply y over k over x. This is commonly used as the model for the inverse variation, where of course k is the constant of variation. Okay, so y equals k over x. This is the inverse variation. This can be technically read as y varies inversely as x. Okay, so y varies inversely as x, or it can be read also as y is inversely proportional to x. Okay, so First, in solving inverse variation, specifically if we are looking for a desired value, first and foremost is we will solve or look into the value of the k. So solving for k, where k is the constant of variation, you can have here solving for k. So y equals k over x. This is our inverse variation. We will solve the k first. So to solve for k, we will eliminate x in the denominator. So by multiplication property of equality, we can eliminate x by multiplying both sides by x. Okay, x times y. So we can cancel the x here, the numerator and denominator. So k times x over x, what is left is k. So in the left side, still x times y. xy equals k. So this is how to solve the k. If ever you have another set of pair x and y, say y subscript 2 equals k over x subscript 2, solving for k again, so k over x subscript 2 by multiplication property of equality, you can have here, so x both side is the right side, x subscript 2, then the left side x subscript 2 times y subscript 2. So k is clearly cancel x subscript 2, x subscript 2 in the left side times y subscript 2 equals k. So here in the first pair, xy equals k. In the second pair, x subscript 2 times y subscript 2 equals k, and so on. Okay, if we in general, we can have here x subscript n times y subscript n is equal to k. Okay, take a look. In solving inverse variation, we can translate k to what? To relate x and y. So as we can equate the values of k here, xy, x subscript to y subscript to, and with this, say in these two set of pairs, so we can have here as k, we will equate the values of k here. This is k equals xy, then another k is x subscript 2, then y subscript 2. Or to make it particular, this is our first pair, x subscript 1, then y subscript 1. Okay, also this model can be used aside with y equals k over x. It can be used to get the desired value of a particular quantity. Okay, for this I will give you an illustration to really show the inverse variation. Okay, example. The following table is the relationship of number of workers W and number of days presented by D. So this is our table here. Okay. Okay, in our first row, this is the number of workers, and our second row is the number of days. Okay, we are tasked to comply this A, B, and C. What type of variation? B, solve for the K or the constant of variation, and C is find D or find the number of days when W of or workers is equal to 8. So first is we will analyze the table here. As you can see here, this is the values. The number of workers at first is 2. To complete a job, 2 needs how many days? 24 days. Okay? Do you follow? Then another pair. The number of workers is 4. So out of 4 workers, they need how many days? They need 12 days. So out of these values, I think we can actually analyze. So number of workers, 2 needs 24 days. As we increase 2 to 4, it needs 12 days. So can you guess? A now, what type of variation? So 2 increases to 4 and 24 decreases to 12. So our first variable here increases. So as we increase the values of the first quantity, we able to decrease, or it causes or produces a decrease in the second quantity. 2, then 4, then 24 becomes 12. Okay, normally in this type of problem, as we increase really the number of workers, we lessen the number of days. Okay, so it clearly shows that this is what type of variation. So here we have our solution. As we increase the number of workers, we can lessen the number of days. Solution A is what type of variation? This is inverse variation. Okay, as we increase the first quantity, it causes a decrease in the second quantity. Okay, letter B. Solve for K, or the constant of variation. First is, to get the value of K is, we will first translate our quantities. So we know that inverse variation is simply y equals k over x. Okay, our x here is w and our y is days. So we will substitute. We have d equals k over what? W. This is d varies inversely as w, or d is inversely proportional to w. So solve for k. How to compute k? So we can actually use this pair, 2 or 24, or 4 and 12. So we will use this second to make it simpler. So solve for k. So k, d now is, our d is 12. So here 12 equals k over 12 day, 12 for days, then our w is 4. Okay, here since we are solving the value of k, we will eliminate 4 by the multiplication property of equality. We have here as k over 4. We will multiply both sides by what? By 4. So on the right side, multiplied by 4, and same with the left side. So I think we can cancel 4 and 4 in the denominator. So k times 4 divided by 4 is, what is left? K. Then 4 times 12 is 48. So the value of our k is 48 here. So this is 48, the value of our k. Even if we will solve for the first pair, we can still get the value of k here. So again here, we will try 2 and 24. So D varies inversely as W, we will try if really we can get or arrive K equals 48. So our D is, say, 24. Then K over 2. Again, by multiplication property of equality, K over 2 can multiply to cancel 2 in the denominator. We can multiply both sides by 2. So on the left side, 2 times 24. Okay. Cancel 2. K is C. 2 times 24 is 48. So still here, the value of K is 48. Meaning to say, we have a constant of variation in relating two quantities. So I think we've done with A. What type of variation? The type of variation is inverse variation. Solve for K. The value of K is what? 48. Next, C. Find D when W equals 8. Here, since we have already the value of our K 48, we can solve for the value D. Here we will put here. What is the value of D when our W of our workers is 8? Here, since we increase our workers from 2 to 4 to 8, expect that our value of days here is lesser than 12. So 24 down to 12 down to a certain value. So how? Okay, we will use this model. Okay, here we will use that. So D equals K. Instead of writing K, we will use 48. So D equals 48 over what? D 48 over W. Okay. What is D when our W is 8? So what is D? So we will replace W by 8. So 48 over 8. Our D is 6. So 6 when W is equal to 8. So here, this is now equals to 6. Okay? We will check. 2, 4, 8 increases. 24, 12, 6 decreases. Now, wow. We can have another solution, second solution. As you can recall, we have, or we can relate x and y using the value of k. Can recall k is what? We can represent in this way: x subscript 1 times y subscript 1 equals, since we have a constant of variation, the inverse variation can be presented as the product of the quantities. This is x subscript 2, y subscript 2. Since our x subscript 1 is 2, so we will replace here 2. Our y subscript 1 is 24. Okay, equals to x subscript 2. This is actually our 8. What is y subscript 2 when x subscript 2 is equals to 8? So this is 8. Then this is our unknown D. Okay, or y subscript 2. Then solve for y subscript 2. So 2 times 24 is actually 48, equals 8 times y subscript 2. Okay, dividing both sides by 8 to eliminate 8 here on the right side. So you have 48 over 8. So here 8 over 8. Or you can simply multiply both sides by 1 over 8. Y subscript 2. Let's cancel. What is left here is 48 divided by 8. Oh wow, we can still arrive at value of 6 equals y subscript 2. Simply, if therefore simply if w equals to 8, then our d becomes 6. So this actually arrives at the same value using this first procedure here and our second procedure. Okay, I will give you last example. Example number 2. This is our last example. Here we go. If y varies inversely as x and y equals 12 when x equals 3, find y when x equals what? 9. Okay, if y varies inversely as x and y equals 12 when x equals 3, find y when x equals 9. So there's no need to identify what type of variation because it clearly stated as inversely. So we will use inverse variation. Okay, inverse variation. So find y when x equals 9. So solution. Okay, again and again, I think it is better for us to make a table here. So this is for x, this is for our y. First is we will use the pairs or the given values. First is when x equals to 3, y is 12. Okay, this is the first given condition. Find y. So this is our problem now. Find y when x equals 9. Okay, since we are sure that this is inverse variation, still we can analyze. 3 becomes 9, so it increases. Then 12, since this is expected to be in decreasing, so expect that the value of our question mark here is lesser than 12. Since we increase the value of our first variable, it is expected that the value of the second variable or the second quantity is what? Less than 12. So how? So first is we will solve the value of k. So y varies inversely since y and x are used as quantities, so no problem. So y, so what is the first symbol here is the one what is being first used. So if this is m, so use m varies inversely. So this, since this is y, so y varies inversely, so y equals our model k over x, so no problem. Y varies inversely as x, or y is directly proportional. I mean, y is inversely proportional to x. So solve for k. We can solve k here by using this first pair. So y is 12, then k over, what is our x? 3. So again, we will eliminate 3. So k over 3, we will multiply both sides by multiplication property of equality. We will use 3. So the left side, 3 times 12. So simply cancel. K equals 3 times 12. This is, wow, this is 36. Okay, so 36 equals k. After that, we can actually solve now the value of our y when x equals 9. So here y equals again k over x here. Then since we have already the value of k, so y equals, we will use 36 over x. What is y when x equals 9? Okay, what is y when x equals to 9? So y equals 36 over 9. What is 36 divided by 9? So y is 4. So we will check. 3 becomes 9, increasing 12. Oh, we hit the value 4. So the question mark equals 4. We'll try our second solution to really check if we have the correct answer. Second solution. Recall K relates to quantities x subscript 1, y subscript 1 times y subscript 1 equals x subscript 2 times y subscript 2. X subscript 1, we have here 3. So 3 times the pair 12. Then x subscript 2, this is 9. If x is 9, what is y? So use y subscript 2. So 3 times 12 is 36. Then 9 equals 9 times y subscript 2. We will eliminate 9. So we will just divide here both sides. So 9 divided by 9, so 36 divided by 9. So cancel. Wow. 36 divided by 9 is 4. So the same with our first solution. So again, in our table, x is 3, then y equals 12. What is y when x equals 9? The answer is 4. So our x increases, it causes y, or produces y, so it decreases. 12, 4. Okay, I hope you learn something about my presentation in inverse variation. Thank you, and may God bless us all. Thank you.